Right, so today's objective is going to be to find the domain and range of a function. So that is what this chapter 5 is going to be all about. It is always going to be about functions. So we'll define what a function is first, and then we'll go on with 3 examples for today's lesson. So a function is a relationship that pairs each input with exactly one output. The domain is a set of all possible input values, and the range is a set of all possible output values. So what this is saying is you put one number in and you get one number out. So take a look at this machine right here. So it inputs one number, and here is my function y equals 3x, and my output is my result. So domain is a possible input values, and range is all of my possible output values. Okay, so here's our first example. Find the domain and range of the function represented by the graph. All right, so let's take a look. So here's step number 1. I would always say write the ordered pairs down. Write ordered pairs. So let's take a look. So I have 1, 2, 3, 4 ordered pairs here. So let's write that down. So it looks like this one on the very far left is -3, -2. Next one is -1, 0. I have 1, 2, and I have 3, 4. So that's step 1. Step 2 is fairly simple. So here is, so as we said earlier, the domain is all my input, right? So domain is x values, and range is y value. So how can I use what I just did in step 1 to help me out? So pretty much what this is saying is, I'll use a different highlighter color. So I'll use yellow for domain. So domain is my x value. So my x values are -3, -1, 1, and 3. So my domain, I can just label as D, is going to be -3, -1, 1, and 3. It's that easy. Range, I'll do orange, is all of my y values. So take a look, -2, 0, 2, and 4. So my range is -2, 0, 2, and 4. And that is it for example number 1. So if you're confused, pause this video, try it again, and then move on from there. Alright, next example is, so now instead of given a table or graph, we're going to be given a table. Okay, so the function y is equal to -3x plus 12 gives the amount y in fluid ounces of juice remaining in a bottle after you take x amount of gulps. The domain is 0, 1, 2, 3, and 4. What is the range? As you said earlier, the domain is the input, what you put in. Your range is your output. So I'm given my function. Here's my function right here. Y equals -3x plus 12. So this is where the XY chart comes in handy. So what are my inputs again? It looks like my domain are those values, so 0, 1, 2, 3, 4. So now what this is saying is, if I plug in 0 for x, so I'm taking this function right here. So plug in 0 for x. So at x equals 0, y equals -3 times 0 plus 12. -3 times 0 is 0. So I get 12. So at x equals 0, y is equal to 12. And I do that for all of them. So at x equals 1, right? So now we plug in 1, negative 3 times 1 plus 12 equals, so negative 3 plus 12, this is 9, okay? At x equals 2, y equals negative 3 times 2 plus 12, negative 6 plus 12 equals 6. All right, so you could keep going on and on and on. But hopefully you're able to see a pattern by now as well, right? You see how I'm going up plus 1, and going down minus 3, minus 3. If I'm going down a consistent pattern for both my x and y, so my next one's going to be 3, my last one's going to be 0. So you can use these tricks to kind of speed up the process, because I know sometimes it can get tedious, so you could use that to help you out. All right, here is the last example for the day. The table shows the percent y in decimal form of the moon that was visible at night x days after May 19, 2014. Interpret the domain and range. B, what percent of the moon was visible on May 21 of 2014. All right, so word problem. So it says interpret. Okay, so that's it's a little different, right? So let's identify a domain or range. So my domain is always going to be my x. My range is always going to be my y, right? So let's figure this out. So after 0 days, why is it 0 days? Because it says x is equal to 0, right? So after 0 days, what is the date? The date is May 19, 2014. So after 0 days, it is still May 19. Okay, what about after 1 day? Right? Because it says 1x days after. So after 1 day, it'll be May 20. After 2 days, it is May 21. After 3 days, so on and so forth, it is May 22. So that's what it means by interpreting the domain. So this is all for my domain. Now let's talk about my range. I'll just do it right on the bottom. So all my range is saying is percent of moon that was visible, right? There's no really way I can use these numbers to help me interpret it out. So where did I get that? Well, take a look at my units for my y. My y is the percent of the moon that was visible at midnight. Okay, so that's all you have to write. So percent of moon that was visible at midnight. So that's how you interpret your domain and range. Domain is you have to use what your x values represent with the context of the problem and figure that out. Range is pretty much units of what I'm measuring. So that is also what will help me out. So that was all for part A. Okay, so now let's do part B over here. So what percent of the moon was visible on May 21st, 2014? Well, simply based off my table. So if I were to look at this table right here, it'd be a little hard. I don't know when May 21st is. So this is why interpreting was so important, because now I know when May 21st is. Why? Well, it's right here. After 2 days, it is May 21st. So which column am I going to be looking at? I will be looking at this column right here. So at I don't want to use that color. At May 21st, 39% of moon was visible. All right, so that was everything for the notes for today. So why don't you guys go ahead and work on your own statements and fill it in on Edpuzzle, and afterwards also fill and reflect how you guys feel after today's lesson. So by all means, if you were confused at any point, feel free to go back in this notes and figure it out, and then tomorrow we will work on our homework. All right, good luck.